Hi, today we're going to be talking about section 4 from chapter 2, which is titled Rates of Change and Tangent Lines. We're going to be talking about average rates of change, tangent lines to a curve, slopes at a curve, and normal slopes to a curve. So it's actually mostly stuff we've already done. We're just putting more specific names on things. What I'd like you to do is try example 1. Find the average rate of change over the specified interval. So from 0 to 2, remember it's just the change in y over the change in x. So find those values and see if you get the right answer. Hit pause. Okay, so if I was going to do this, it would be f of 2 minus f of 0 all over 2 minus 0. So let's see. If I plug in a 2, 2 times 4 is 8, plus 1 is 9. Square root of 9 is 3. Minus 4 times 0 is 0, plus 1, square root of 1 is 1. Over 2 equals 1. So the average rate of change over this interval for this function would be 1. Hopefully you got that right. Moving on. Estimate the slopes of the secants PQ, Q1, PQ2, PQ3, and PQ4, arranging them in order on a table. What is the appropriate units for these slopes? Remember that a secant is just the line that connects 2 points on a curve. So we just want to find those slopes. So for the very first slope, I'll see if I can draw a line fairly well. I don't know, it probably won't be very good. But draw the line. We're just trying to find the line that connects P to Q1. So if we draw our little slope triangle, you can break it down into delta x and delta y. So my change in y here is going to be from 20 to 80, which is 60, over change in x is from 5 to 10, so that's 5, which equals 12. So the first one, P Q1, is 12. And we'll kind of keep moving down here. Just get rid of that triangle now. So we're going to be working with a different one. So now for Q2, I draw a new triangle. That looks like it's going to be, well, this will be P Q2. Maybe we'll call it 38. No, it's just kind of an estimate. 38 up to 80, so that's going to be 42 over a distance of 1, 2, 3. 42, well, 30 divided by 3 is 10. 12 divided by 3 is 4. This would be 14. These are just estimates. Okay, you do the rest and see how you do. Hit pause. So let me get rid of this one. Oh, it won't. Now that I already hit pause, it won't get rid of it. But anyway, this is the new triangle I'm working with. So let's say that's at about 56. So P Q 3, 56 over, it looks like about 1.5, 1.5, which is equal to, let's see, it's 37 1/3, but we'll just, since we're rounding, that can't be right, sorry, it's not 57. Let's change that to 27. Maybe that's too much. It was at 57 up to 80. Okay, sorry. 57 up to 80 is 23 over 1.5. And we do 23 divided by 1.5, we get 15 1/3, so we'll just estimate that to be about 15. Well, we'll put 0.3. Okay, sorry for that. My brain got stuck for a second. It happens. So then the last one, PQ4, let's call that from 71, so we'll say 9 over 1/2, so 9 divided by 1/2, which equals, it's an estimate, so 18. Okay, so if we're looking at this, we went 12, 15, 18. If I was going to estimate the speed at P, I would say this would, a good estimate would be about 20, and then this would be meters per second. Okay, 20 meters per second for the units. So hopefully that's about what you estimated you got. It didn't have to be perfect, it's just an estimate, just so we're thinking about what is the slope at a specific point if we're estimating. Okay, I want you to try this one then. Find the slope of the following curve at the equation, following curve and find the equation of the tangent. Okay, now the tangent is just the line of that crosses the curve with the same slope that curve has. So if you want to see what it looks like, well, I'll let you try it first. You're basically doing the same thing you did, trying to find as small a point as possible. So remember, from 2.1 we estimated and we found slopes at specific points. We just made that point, the 2 points away from each other, really small. So go ahead and hit pause and try the same thing here. Try to find the specific slope at x equals 1. Hit pause. Okay, so if we do f of 1 plus h, and we're going to make h really small, plus f of 1 all over h. Actually, I'm going to change this a little bit and change these back to x's just to try a little different this way. So if we plug this in, we would get, well, let me do it down here. Erase that. Might even try to give me a little more space down here. So let's try x plus h squared minus 4 times x plus h. By the way, we're finding the limit as h goes to 0. Limit as h goes to 0. And then, so that's the first point, then minus f of x, which would just be x squared minus 4x. And this is all over, if we did it, it would be x plus h minus x. That's how those, that's just left with h. I guess I probably should have done that in the first step. So those cancel the numerator. Simplifies this piece, goes to x squared plus 2xh plus h squared minus 4x minus h minus x squared plus 4x all over h. Again, this is the limit as h goes to 0. So x squareds cancel. My 4x's cancel. I'm left with 2xh plus h squared minus, well, that should be a 4h right there, minus 4h. So I'll factor out an h from all those, so the numerator would just be h times 2x plus h squared minus 4 all over h. And this is the limit as h goes to 0. So that is equal to, if I have the h go to 0, I just have 2x minus 4. And then if we plug in a 1, 2 minus 4 is negative 2. So negative 2 is the slope of the equation. So just pop that into point slope or whatever you want. Let's see. I need to find the y value here, so it would be y equals 1 squared minus 4 times 1. So that's 1. That's negative 3. So I've got my slope m equals negative 2, my point 1 comma negative 3. So I'll plug that into point slope, put it into y equals mx plus b, we get y equals negative 2x minus 1 will be the equation. To get that, I just go negative 3, so that's my y value, equals m, negative 2x would be 1, plus b. Okay, so then I add that 2 over, leaving me b equals negative 1. So there's the equation of the line tangent to this curve. Here's the graph of that. You can see the parabola is graphed there, and then at that point right here, that's at 1 comma negative 3. You can see that is where it crosses, and you can see the tangent line there just crosses perfectly there with the equation negative 2x minus 1. So that's what it looks like on a graph. Here's the definition of a slope at a point, so it's what we've done now. It uses m as the slope, so we're just finding the f of whatever that a value is plus h minus f of a over h as h goes to 0. This is the definition of a tangent, right? This is the tangent line, so slope of the curve at a point is the slope of the tangent. Okay, this time try this. Hit pause. You're going to find not a specific value, but at an a value. So if you use what I just did and leave it as an x, you can easily substitute in the a. So hopefully that helped you out a little bit on the last one. Go ahead and hit pause. Okay, so let's try this. It would be f, the limit, as h goes to 0 of 9 minus parentheses x plus h squared minus parentheses 9 minus x squared all over h, which equals the limit as h goes to 0 of 9 minus x squared plus 2xh plus h squared minus 9 plus x squared all over h. Those cancel, these cancel. I'm left with 2xh plus h squared. This equals the limit, and I'm going to go ahead and factor out an h in the numerator. So I just have h times 2x plus h all over h. So those cancel. That equals 2x as h goes to 0. So the slope at x equals a would just be substituting that a to a. So hopefully that helps you. So at any value on this curve, the slope is 2 times whatever a is. So if it was 1, it'd be 2. If it was 4, it'd be 8, and so on. Find the equation of the normal of y equals. So if we had a parabola, right, and we have a tangent line crossing right there, the normal curve is just the line that is perpendicular to the tangent. So just in case you forgot that. And so perpendicular lines, if we find the slope of the tangent, we just take the opposite reciprocal, and that gives us the slope of the normal line. Well, this is important with friction, when you're dealing with friction in equations, because you need to have that coefficient of friction in physics, which is all based off of that normal force going straight into the ground, perpendicular to the ground. So go ahead and hit pause, see if you can figure this one out. Okay, if we try this one, we're trying to find the slope again. So the slope is just the limit. As h goes to 0, we plug in, instead of x everywhere, we do x plus h, so it's x plus h squared minus 3 times x plus h minus 1 minus parentheses x squared minus 3x minus 1 all over h. So we're going to find the limit as h goes to 0 of x squared plus 2hx plus h squared minus 3x minus 3h minus 1 minus x squared plus 3x plus 1 all over h. So my x squareds cancel. My negative 3x's cancel. My 1's cancel. And I believe I'm left with 2hx plus h squared minus 3h all over h. So again, let's write that out. Limit as h goes to 0 of 2hx plus h squared minus 3h all over h, which if we factor an h out, h times 2x plus h minus 3 all over h. As h goes to 0, those h's cancel, plug in a 0 for h, and we get 2x minus 3. So if we plug in the 0 for x, we get this equal to negative 3. So the slope of the tangent line is equal to negative 3. So the normal is perpendicular to that, so that's going to be the opposite reciprocal, so it should be the slope of the normal would be 1 over 3. Okay, So that's our slope we're going to work with. Then we need to find the y value, so plug in 0 into the original equation. We get 0 squared minus 3 times 0 minus 1 is just -1. So m, again we said was the slope. The point is 0, comma, -1. So if I go y, which is -1, equals m, 1/3 x, which is 0, plus b. Okay, those cancel. B equals -1. Oh, that would have made sense. This is my y-intercept, so I could have just plugged it straight in. Y equals 1/3 x minus 1. So that is the equation of the normal curve. Next, what is the rate of change is just slope, of the volume of a sphere with respect to the radius when the radius is r equals 2 inches? So we're just going to find the slope of this equation. It would be the same as if it said y equals 4/3 pi x cubed, but we're doing it with respect to the radius now, and it's talking about how does the volume change, or the rate of change of the volume, instead of how does the y change, or most of the times y has been distance when we've been talking about rate of change. So looking at this, we would go the limit as h goes to 0 of 4/3 pi, and then r plus h cubed minus 4/3 pi r cubed all over h, which goes to the limit as h goes to 0 of, well, if you cube that r plus h, you get, we'll write the 4/3 pi times, that would go to r cubed plus 3r squared h plus 3rh squared plus h cubed. If you didn't get that right off the top of your head, just do r plus h times r plus h times r plus h, and you'll get that answer. Minus 4/3 pi r cubed all over h. So I'm going to actually factor out this 4/3 pi. Just so we can have it on the outside to kind of be able to ignore it until the end here. Okay, then I can just work on the inside here. So I've got this canceling with this. So in the middle, I should just have this limit as h goes to 0 of 4/3 pi. If I factor, well, I won't factor yet, 3r squared h plus 3rh squared plus h cubed all over h. Okay, I'm going to try this a little different just so you can see it different. This h cancels with that, takes that down to an h, takes this down to a h squared. So this equals and then plug in zeros for my h and h squared. Just leaves me with 3r squared. and my radius is 2, so that's 3 times 2 squared, which equals 4 times 3, which is 12. So the rate of change of the volume when the radius is 2 inches would be 12, and I would say it'd be inches squared per, if we're talking units of time per second. Okay, so that's a word problem for you. Hopefully that helps out with some of the word problems. Remember, it's just finding slopes, so we just take whatever the equation is and use your limit as h goes to 0 by increasing your y values by h, and yeah, go that way. So I hope that helps you guys, and we'll see you in class. Please bring all your questions. That does it for Chapter 2. Thank you.